Let's do this one last time, guys, but today we're going to take into this last one, we're going to take into account friction, because I really didn't mention that much before. And I'm not just going to talk about friction on surfaces, I'm going to really do friction on surfaces, but also in my pulley as well. So I'm going to have two sources of friction. This first one, though, is actually quite simple. There's no surfaces, there's just friction in my pulley. So let's say, keep it very simple. Let's say we've got a force of gravity here. And we've also got a force of gravity here. Now, which one do you guys want to be bigger? Let's say A is going to be bigger. Let's say that we have FGA equal to 10 newtons. And let's say we have FGB equal to 5 newtons. Oh my goodness. What's going to happen, guys? This is going to rotate like this. But maybe not. Some people saw today or yesterday in the class that we had some problems. And the problems arose when we had friction. Now friction is going to occur up here, and it is with the surfaces with the rope, and it's going to oppose motion. Now if there was no friction, this would clearly rotate like so. It would rotate around. But we may not have that happen because we have friction. If friction is going to go in the opposite direction. Now think of this though. I would put it right here, but you can put it wherever you'd like. And it doesn't really matter what angle it's at. You just have to realize that the friction from this pulley is going to be in the opposite direction of this. So let's write up our F net. I think we'll see it when we write up our F net. So F net is going to be, I'm not even going to take into account my tensions anymore. You can if you really want. It's not a big deal. But I am just so post tension. That's pretty funny for me. Now, something to realize, when you calculate these should be negatives, because they go down. So let us punch in our values and see what we're going to get. F net is going to equal, I'm just leaving the F net off, negative 10 newtons. And let's make our force of friction a value. What's our value? 3 newtons. Okay, so we have a force of friction of 3 newtons. Now, this is our FA. Here's our FB. It's negative 5 newtons. It goes this way. It's right there. And then we're going to have plus 3 newtons. Are we done? No, because we have some... Are we done? No, we have some major problems up here, guys. Now, take a look. I have my FA, or FGA, as negative 10, and I have my FGB as negative 5. Now, before that was right. They're both going down. But they pull the pulley in different directions. This is the direction my A pulls. My B pulls this way, though. So I need to make them going in opposite directions. So I'm just going to make this positive. Okay, now let's look at the direction the friction goes. Does the friction go in direction A or B? It goes against A, so it's going to have to be positive as well. And right here, this right here, guys, is what you need to do to solve for your F net in this problem. I think we're going to get an F net of negative 2 newtons. Okay, great. Let's look at a little bit more complex one. Let's come up to this guy. And let's add in our forces real quick. I'm going to leave our tensions off. Some of you guys, tensions are a lot of fun, but after a while you get kind of tired of doing them. Now, I'm going to add these guys on, but later on you'll realize that these can also be forgotten. Oh, I don't know. Oh, whatever, that's fine. And our last thing is we have a friction here. Now, which way is this system going to go? Well, we have a huge mass here. It should hypothetically, if everything goes according to plan, it should want to go like this, right? Oh, that's not what I want. Come on. It should want to go like this. The force of B is going to want us, or the force of gravity of B is going to want this pulley to turn this way and pull the whole system down. This is going to want to go to the left. Why might I not want to go to the left? Well, let's put in some of our stuff. Mr. Shaw, let's label things. You have your FGB. That pulls us down. Here you have the normal force of A. Here you have the force of gravity of A. Here you have a friction force because FA is sliding across a surface. We'll call it FA, or FFA. That's the force of friction of A sliding across the surface. Because we're going to have something we talked about in the last one. We're also going to have a force of friction here with the pulley. And it's not going to want to turn the way FB wants it to turn. It's going to go in the opposite direction of FB. The force of friction is always going to go in the opposite direction of where the motion wants it to go. We call it FFP, the force of friction of our pulley. Now, real quick, we should get a hint that this guy and even this guy, they're equal but opposite. They end up canceling out. So we should see that when we calculate our Fnet is going to equal FGB plus our FFP plus our FFA. Now FFA is from sliding across the surface, and FFP is the friction within a pulley. Now one thing to remember, guys, let's say we had values here for these. Let's give them real quick. Let's say that this is going to be 10 newtons. It's negative, it goes down. And let's say this is going to be 6 newtons, and this is going to be 4 newtons. We'll get an interesting experience here. So if we have this friction, this friction, this friction, when we add these up, this is negative 10, this is 6, and this is 4. When we add these up, well, we should see that they may. This is not how it's always going to happen, guys. This is just a freak anomaly. They should add up to 0. And in this case, if this system hasn't moved yet, it will not move. Or if this system is moving, it'll move at a constant velocity because it's at equilibrium. So it's either at rest or it's traveling at a constant velocity. Cool. Talk to you later.